Question 2. A manufacturer uses a machine to make metal rods. The length of a metal rod, L centimeters, is normally distributed with a mean of 8 centimeters and a standard deviation of X centimeters. Given that the proportion of metal rods less than 7.902 in length is 2.5%, part A, show that X is equal to 0.05 to 2 decimal places. Now, because we have a normal distribution here, but we don't have the mean and standard deviation, I know I'm going to need to look at the standardized values. So this is from our formula booklet. These are the standardized values. So this is when you take a normal distribution with a mean of 0 and a standard deviation of 1. Now we're interested in our probability being less than 2.5%. So that's this 0.025 in our table, which gives us a z-score of 1.96. So looking at our normal distribution curve, 1.96 is the positive value we get from the z-table. We want the negative value of this, which we can take due to the symmetry of the normal curve. And the reason we want the negative value is because we are looking for the proportion of metal rods less than this 7.902, and we know this value also to be less than the mean. Now you should remember your z-score formula, so that is z is equal to x minus mu over sigma, where x is the individual value we're looking at, in our case 7.902, mu is the mean, in our case 8, and sigma is the standard deviation we want to find. And so, putting in our value found from the table, minus 1.96, and our value of 7.902, and our mean of 8, we are hoping to rearrange this to get a value of 0.05 to 2 decimal places. And thankfully, we do. Part B asks us to calculate the proportion of metal rods that are between 7.94 centimeters and 8.09 centimeters in length. Luckily for us, this can be done straight in our calculator. So now I want to find this probability on this normal distribution being between the values of 7.94 and 8.09. So if we go to Menu, Statistics, I want a normal cumulative distribution, so number 2. I know my lower bound is 7.94 equals. My upper bound is 8.09. My standard deviation I've already shown now to be 0.05. And my mean value is 8. And we get our probability to be 8.4900 and so on. And we get an answer of 0.8490 and so on, or 0.849 to 3 significant figures. A lot of information here. So the cost of producing a single metal rod is 20p. A metal rod where the length is less than 7.94 is sold for scrap for 5 pence. When it's between 7.94 and 8.09, it's sold for 50p. If it is greater than 8.09, it needs to be shortened for a cost of 10p and then sold for 50. We want to calculate the expected profit for 500 sold metal rods. So if we have 500 rods, they will be of these varying lengths. So we want to work out how many are going to be within each of these categories. So we want to know the probability that the length will be less than 7.94, that it will be greater than 8.09, and that it will be between 7.94 and 8.09. Now these values can all be found and stored on the calculator. I'm going to show the process here of finding all those probabilities and then storing those values in our calculator for use in the rest of the question. So we're going to go to our statistics mode, number 7. We're looking at a normal cumulative distribution, so we're going to click 2. Now for the first one, I want less than 7.94. For the lower bound, I'm going to say 0, as my rod cannot go lower than 0. The upper bound is this 7.94. My standard deviation is 0.05, and my mean is 8. This gives me a value of 0.11506 and so on. I'm going to store this as A on my calculator, stored to A. Now we're going to find greater than, so if I hit equals again, I go back to my menu. So now my lower bound is my 8.09. My upper bound is going to be infinity, so we're going to hit 99999. My standard deviation and mean are remaining the same, so when we hit equals, so the probability it's greater than 8.09 is 0.035 and so on, and we're going to store this in B. And then lastly, I'm going to get back the probability of being between, so 7.94 as my lower bound and 8.09 as my upper bound, and I have my probability of 0.849, and we're going to store this as C. If we go to Shift Recall on our calculator, I can see now that I have those 3 values stored, safe for use later on in the question. Now let's look at what we need to calculate our expected profit. So let's first look at our expected income. Now our income is income times the probability times the amount. Now the probability times the amount, this is giving us our expected number of rods with each length. Our income is the value that we get from each sold rod. So when it's less than 7.94, we get 5p. If it's between 7.94 and 8.09, we get 50. And for this final case here, if it is greater than 8.09, it costs us 10p to shorten it, but then we can sell it for 50. So our income for these lengths would be 40. 5p income from those less than, which is estimated to be 0.115 times 500. For those in between, we have our 50p times the probability it has a length between 7.94 and 8.09 times by the amount, which is 500. And then lastly, we have 40 times 0.035 times 500 for those that are greater than 8.09. We can use the exact values on our calculator to get the following, which gives us an income of 22,231.27. Now I am in pence at the moment. Now profit, we want to find the expected profit. Profit is our income subtracting our cost. We had this line at the start here, the cost of producing a single metal rod is 20p. So for all of these rods, there was an initial cost of 20p. This means that our income currently of 22,231, we need to subtract 500 times 20, which was our initial cost for each rod. It gives us a final value of 12,231.27. Again, I'm in pence. I want my answer to the nearest pound. So my expected profit is £122. Part D. The same manufacturer makes metal hinges in large batches. The hinges each have a probability of 0.015 of having a fault. A random sample of 200 hinges is taken from each batch, and the batch is accepted if fewer than 6 hinges are faulty. The manufacturer's aim is for 95% of batches to be accepted. Explain whether the manufacturer is likely to achieve its aim. Let's first look at the distribution here. If we consider a binomial distribution, we have 200 hinges is our sample, and we have a probability of it containing a fault of 0.015. I want to know what the probability is that less than or equal to 5 hinges are faulty. This is because with a binomial, if I want less than 6, I need to take less than or equal to 5, as binomial is a discrete distribution. On our calculator, so we have a binomial distribution, so let's go to stats mode 7. I want binomial CD, so number 1 as a variable. Now this time I want less than or equal to 5. N is 200, and the probability of a fault in these hinges is 0.015. Gives me a probability of 0.917 and so on. 0.917 and so on. Now, since this value that we've found is less than 95%, which is the manufacturer's aim, it is unlikely that the manufacturer is going to achieve this claim, because we have calculated that actually only 92% of batches, rounding up, would be accepted.